Hi, Sunshines. Hi, Sunshines. So, we're going to talk about 3D figures, identifying 3D figures step by step. As we do our 3D figures chapter, mostly you're going to be calculating volumes. And in order to choose the correct formula, you have to have the right shape. Choosing which formula to use is a really big deal. So, I want to make sure that you guys have this. So, this is a step by step approach. So the first thing you can do is look for circles. If you have one circle and a point, then that's a cone. You have a circle and a point. If you have two circles and then a curved wall around it, that's a cylinder. So I got two circles, and then here's the wall curving around it with the ravioli can. You can't see the second circle because it's opaque, but you know that it's there. Next up, once you've eliminated circles, then you look for rectangles. So prisms are constructed mostly of rectangles. If you have exactly 6 rectangles making a box, that's a rectangular prism. If they're squares, then it would be a cube, which is just a special kind of rectangular prism. If you have two of a shape that's not rectangle, but it's connected by a bunch of rectangles, then your weird shape is the base. So this is a hexagonal prism. So it's got a hexagon, and then there's a hexagon on the bottom that you can't see, just like with the soup can because it's opaque. But then it's connected by rectangular walls. And then so you see there'd be 3 more walls in the back. Here I've got 2 triangles that are connected by 3 rectangles, one for each side of the triangle. Same thing with the tent. You've got the 2 walls and the floor of your tent that are connecting the front and back of the tent that are triangles. Toblerone box, again, it's 3 rectangles, and then the 2 triangular ends. So the triangles are the base of my prism, and then the rectangles are the walls of your prism. 2 octagons, there's one on top, and you know that there would be a matching one on the bottom. When you look at that intuitively, you should recognize that shape. And then again, you name it base plus the word prism. So this is an octagon, and then you kind of make it into an adjective. So instead of saying octagon prism, it's really octagonal prism. But honestly, I don't care if you call it an octagon prism, as long as I care more that you're getting the point and choosing the correct formula and understand that it's an octagon and it's a prism than I care that you know how to convert the word octagon into an adjective. But the proper term would be octagonal prism. Next up, you look for triangles. Pyramids have triangular faces along the lateral surface. So if you have exactly 4 triangles just stuck together, that's a triangular pyramid where one triangle is the base and then the remaining 3 triangles are your lateral surface. If you have a different shape and a bunch of triangles, then this is a pentagonal pyramid. This is a square pyramid. And then you have the triangular faces connecting up to that apex. So again, just like with the prisms, it's the name of the shape and then the word pyramid. So you should be saying rectangular pyramid. Square, the adjective is also square. This is pentagonal pyramid because it's a pentagon for the base. Know that that weird shape is your base. So when you go to calculate your volumes, you need to find the area of that weird shape, the base shape, and then you're going to calculate your height perpendicularly to the base. So we'll talk about how that works separately. But the key is just being able to identify what is your base shape, what type of shape are you dealing with, because pyramids have very different formulas from your prisms. And then obviously, if it looks like a ball, it's a sphere. If it's totally round, it's a ball, it's a sphere. And then polyhedron is really the name for any shape that's just made of all flat surfaces. But usually when you talk about polyhedron, if you do a Google image search for polyhedron, you're going to get a lot of shapes like this. You're going to get regular polyhedrons or I forgot the word. because we don't really talk about them. Um, uniform. Uniform polyhedrons where so a regular polyhedron would be where it's literally it's all this is a square, that's a regular polygon, this is an equilateral triangle, this is a regular pentagon, and it's repeated throughout. But this little the d10s that I have up here are not regular polyhedrons. That little pizza shape is not, they're not equilateral. Uh, so that wouldn't be considered a regular polyhedron, but it still is somewhat uniform, and that's why they use it for dice, because at least every side is congruent to itself or to each other. You have an equal chance of landing on any of those sides. And then other stuff, you'll deal with hemispheres, which is just half of a sphere, so you should be able to recognize that shape. Again, now the sphere and the hemisphere are pretty obvious. It's pyramids and prisms that people really get tangled up on. This is a geodesic dome that you can approximate it as a hemisphere. Really, it's actually a polygon. Sorry, it's a polyhedron. It is actually all straight sides. I'm not really sure how many triangles are in it. It's probably about 30 little edges to make that bottom of it. So it looks like a big giant circle. It looks like a hemisphere, but it's technically not actually curved. It's all a bunch of little straight sides. But realistically, you almost never need to be that precise. So you could just approximate that as a hemisphere. And that's it. So please, please, please practice your vocabulary. Please practice your vocabulary. Make sure that you know these terms, because you're going to mess up finding the volume is easy. Knowing what shape you're finding the volume of is the hard part.